Okay, so that is the first thing. Yeah, feel free to ask. Something that I do want to, let me actually get to the heart of all of this. I think we have a lot of things to do. If you remember, this was
This meeting is being recorded.
okay, let me, yeah, I'm gonna keep muting people. Sorry. There we go. Mhm. Where is this? Okay, so I see. This is where we are. Just give me a second here. No. So let me actually go back to the presentation that I gave. This was sometime, I think this was early in the year. It may have been January or February when I went to Castroville. And it was a presentation with two of my colleagues. Now, I'm gonna provide a very brief overview of water. Let me actually go back here. My name is Sandoval, Samuel Sandoval. I'm a faculty and I'm an extension specialist. What that means is that I have two jobs and one salary. I work as a faculty and I do all the things that faculty does. I publish papers, I mentor graduate students, and all the things that faculty does. The extension part, what I do is basically I do this type of work with all of you guys, which is basically applied science, okay? Part of my description is to improve the quality of life of people in California. That is actually my job description, so figure that out how that it is. So now, something that you're gonna see here is, as I am doing all of this, I am a hydrologist. I study water, okay? And as part of studying water, I study also how water is used. One of the important part of how water is used is in irrigation. Just to give you a very quick overview, between 40 to 60% of the water that you consume in your house is in the front yard and in the backyard. All the outdoor water use, it's 50% of the water that you consume at home. So this is super important that now you're taking this class because you will, if you do this well, you will save a lot of money. Now, as a hydrologist, I'm gonna give you a very brief overview of water in California. And after I do that, I will start kind of navigating the irrigation in landscapes. Okay, so the first thing here is that, okay, yep, sorry. In California, we have a Mediterranean climate. What does that mean? That it rains in winter and it doesn't rain in summer. For 6 months, we have a drought. It doesn't rain. We have the clear blue sky of California. And if you come from another part that is not California, it is super weird to not have clouds on top of your head for 6 months. But this only happens in California. If you look outside, there are no clouds and they go for 6 months. So that's what you're seeing here. Most of our rain comes in terms of this moisture, of this band of moisture that is called atmospheric rivers. When it rains in California, it rains for 2 to 3 days, and it brings this moisture of water that are called atmospheric rivers. They are called also rivers in the sky. So water is moving on top of the ocean, and as they are moving all this moisture, it will hit the coastal range and it will deposit rain. So when the clouds hit the coastal range, it goes up and it gets colder. It will deposit rain and then it will get into the valley. It will not rain that much. When it hits into the Sierras, because it's very high, it will deposit rain and snow, okay? The most important thing that you need to remember is that it's gonna rain during winter. Most of the water, or the largest amount of water that we need, is during summer. In those 6 months that I tell you that we don't have any clouds, so what that means that we don't have any water, that's when we are using a lot of water, okay? Now, let me actually see if, okay, my computer decided to, okay, here we go. Yep, it decided to stop. Here. And as always, when you are, when you need the technology, something that you have to be sure is that technology is going to fail. So
You got that right.
yeah, so this is nothing new. Let me see. Where am I? I mean, I have way too many slides here. Okay. Now, this is good. This is gonna be. This is how when it rains. This is how the moisture moves into California. This is moisture in the air, and this is an atmospheric river. So something that you should know is that we have these rivers on the sky, rivers of moisture, and this is how we get our rain. If we have 3 atmospheric rivers in a year, we're gonna be in a drought. 6 years, 6 or 7, we're gonna be on a wet season. Now, the next thing that I do want to mention is to provide you, okay. So I do want to provide you where we are in terms of rain in California. Here it is. This is our rain as of today. Here we are. Okay. Sorry, I'm doing a lot of this. So this what you're seeing here that they look like steps. These are the atmospheric rivers. Okay. Now, it will be the normal year. So in an average year, we will have 50 inches of precipitation in this part of the Sierra, in the northern portion. That is if you do only the average. The reality is that as of we're speaking today, we might be in the order of the 30. We are in somewhere here. This is by April, we have 24 inches. We have some late rains, so we'll be here in the 30 inches. We are 20 inches below normal, 20 inches below a regular year, or we are in a 60% of normal year condition. So what that means is that, surprise, surprise, we are again in a drought. By definition, a drought is that any time that a year is below this average, is called a drought year. So if we didn't have enough with what is going on 2020, on top of it, now we have a drought. Sorry, I didn't want to bring this news to you, but yes, we're in a drought. Now, the last thing that I do want to mention, and this will be the last part that I'm gonna touch in terms of California water. In California, I've been talking with you about that it rains in winter and it doesn't rain in summer. In order to move water in time, when it rains and when it doesn't, we need a storage. And the largest storage of California is the snow. What does that mean? That it falls in terms of snow and it stays there. And it is like a valve. Snow is like a very delicate valve that as the weather is heating up, it is releasing water. And that's basically what is happening. This is 2011. This is the year that I started working here at UC Davis. So that's the year, and it was super wet. This is the first year of the drought, okay? This is the snow. These colors are the snow depth. So the colder the colors, it means the more snow depth, the more snow on the ground, okay? This is the first year of the drought. This will be the second year of the drought. This will be the third year of the drought. This is the fourth year of the drought. So the Sierra Nevada, we should call it Sierra because there was no Nevada anymore. There was no snow on the Sierra. So basically that's, yeah, and what we're seeing here, I'm also not in this year that I want to tell you, but yes, this is being more common. This is the 4th year of the drought. This is the 5th year of the drought, okay? Now, what I'm going to show you, this is the drought, the most severe drought in the last 500 years. So again, lucky us, we passed through the drought and now we're passing through a pandemic, sorry. The next thing that is coming is the wettest year on record, okay? So 2011 was one of the wettest years, but not the wettest. So there you go. Here, this is the wettest year. It doesn't look that wet, isn't it? So if you compare it, it doesn't look that wet. It doesn't look with that much snow. Why is that? Because of global warming. Because we have hotter temperature, that's what is going on there. Something that I do want to mention is that, okay, so I'm just kind of checking, okay, here, there we go. Give me a second here, okay, I think we're good. I think one of the reasons why in California we're a little bit ahead of the curve in terms of climate change and global warming, it is because we're feeling it closer. We are the ones that are seeing it pretty much with our own eyes. When we're seeing a year like this with no snow in the Sierra Nevada, it is pretty evident that the weather is changing, the climate. The other thing is that when we're seeing something like this, which is the wettest year and the year that is not as wet as other ones in the past, that's basically what is happening. You should also consider the fog. Typically when I came here, there was a lot of foggy days. We don't have that many fog days anymore. So anyway, so that's what is going on there. This will be 2018, which it was another drought year. And then we have 2019, which it was a wet year. And this is 2020, which it is below normal. Something that I'm calling is that the weather in California is bipolar. It has a bipolar disorder. It's either dry or wet, but it's never in the middle. So anyway, so that's what is going on there. Now, okay, I'm gonna switch back gears here. And I do want to go to here. Now, all the previous thing that I discussed to you, basically, okay, here I have it, sorry. So, now, this is in the past, so we have something that I do want to remind you, this is super important. We do have a problem in California so we have two disconnections, one in time and one in space. So the one in time, basically what I'm telling you is that when it rains and when we need water. So it rains in winter and we need water throughout the year. So we have that disconnection, when things happen and when we need it. The second one, we have a disconnection in space. Basically it rains, or most of our water is in the northeast of the state, and we need water throughout the state. And for that, we have built aqueducts and reservoirs and so on. It comes with certain problems and certain benefits, but that's what we have. Now, from now on, I'm gonna switch gears here. And I'm just gonna be focusing on specifically on the landscape, on the thing that you're coming for this meeting. So, now, the second important concept that I do want you to follow is this. So plants, similarly like us, they need water and they sweat, okay? The sweating of the plants is called evapotranspiration. So, and this is super rocket science, guys. It evaporates and it transpires. The evaporation comes from the soil. So basically, this part of here. So when you put water in here, Some of the water will be evaporated from the soil. Some of that one will get into the plant, and it will go all the way through it until it will go back into the air. When the plants transpire, they catch carbon dioxide. So it kind of, it releases the oxygen, it catches the carbon dioxide. The most important part here that I want you to know, or that I want you to relate, is like similarly like us, the plants, they sweat. And not all the people sweat the same. So that's the other thing that you're gonna see. Not all the plants have the same transpiration. So the more that they transpire, the more water that you need to irrigate. The less water that they transpire, the less water that you have to irrigate. Okay, so this is the concept that I do want you to share with you. This is the evapotranspiration on October 15, 2012. This is in millimeters. So think of an square foot, and this is how much water on that square foot. If you put a volume of water, a sheet of water, this is how much it will evaporate. So this is October, this is November, this is December. What that means is that as the weather is getting colder, the plants don't transpire that much. That's basically what this is telling you. And as we're going into January, February, now March, the plants starts kind of coming back. We have more sun, and because we have more sun, we need more water. This is April, May, June, July, August, September, okay? Now, depending on the year, you may need more water or less water. So this is the same October 12 and October 2010, and this is a dry and a wet year. So this is in October, this is in November, this is in December, January. In February, things are start a little bit. So in a dry condition, in a dry year, you need more water than in a wet year. This is not rocket science. I mean, you already know a lot of this. Dry years, we need more water throughout the year, okay? Now, let me see. Before we go there, okay. Now, this is, so we have now three concepts. The one, when it rains, when it doesn't rain. The second one is a little bit of the, hold it there. Okay, I think we're good. So the second one is this concept of transpiration, that plants sweat, okay? Imagine that you want to know all the plants of all the crops, how they sweat throughout the entire world. Imagine that you want to estimate how much plants sweat throughout the world and trees. It is impossible. It's a lot of work. It's super challenging. So in order to do that, rather than monitoring, so we have two things to know. In order for you to estimate how much water is needed for a plant to transpire, it is the type of the plant and the weather conditions. Those are two very important things. You need to know the plant and the conditions. Now, the problem with the plants is that if we start estimating plants throughout the world, it will be super crazy. It's extremely crazy to think about it. Rather than monitoring all the plants throughout the world, we're monitoring a well-watered grass. So the grass is our template. We are, throughout the world, we are monitoring how the grass grows. And we use a conversion factor of how much water is used the grass compared to a tomato plant, or how much a grass transpire compared to an almond tree. To be even more specific, so on June, the comparison between the grass and the tomato, it might be 0.8. So 80% you need to provide water, 80% to the tomato compared to the grass. And we're monitoring the grass throughout the world, and most importantly, throughout the state. So This that is called ETO is the reference evapotranspiration, is the transpiration of the grass, okay? And this transpiration of the grass, it changes throughout the world because it depends on the climate. And that is it depends on the climate. We use something that is called these KC factors, these crop coefficients factors, which is converting how much it is transpired from the grass compared to the plant that we want, okay? That is kind of the translation factor. The most important, well, you're gonna see it. This here, so this equation here, so the reference evapotranspiration times a factor is the water that the plant needs. That multiplication is the one that you need for your landscape. Here, this ETO, this reference evapotranspiration, we have more than 120 gauge stations throughout the state. So we have stations monitoring how the grass transpire. Imagine that. And these KC factors, there is a database of all the plants that you have in your backyard that you can actually kind of figure out what plant it is. Go into the database, look, and it will tell you what is that conversion factor. So we do have the ingredients throughout the state, okay? So now let me actually, okay, so here it is. So this is something that is called CIMIS. And this is a web page that I use when we have the 120 sites. These are all the different locations of the stations where we are monitoring grass. In this case, the last time that I was with Louis and with the rest of the guys, I downloaded the data from Union City, that it was in San Francisco Bay in Alameda County, okay? But there are different ones. And actually, if you do not know how to get in here or register, let me see. Yeah, this mapping here tells you in inches per month what is that reference evapotranspiration depending on the zone of the state that you are. So for instance, the zone 14, it will be the values in this column, or where you are, zone 5 or zone 4 or 1 or 8, it comes the values on every month. You don't have to know it right now. I mean, that's what I'm recording this, and I'll be very happy to send this map to Louis, so you can actually ask him, and these 12 values, you really need them. These values, you need them, okay? So, let me see. Okay, so we have those stations. The data comes in this Excel format. This will be for Union City, that evapotranspiration. So this is in millimeters per day. So during the summer, it will evaporate a lot. During the winter, not that much. This is only rather than per day. This will be per month, the change. Now, all what I told you, this thing here, so this will come from a map, the map that I just showed you, or CIMIS, which is basically the website that I told you, and you can register on those two, okay? I'll send you the map, and you already have and for CIMIS, you just need to, it is like a regular register, and it will be there. Now, these KC factors come from something that is called, let me see, WUCOs. And also I'll give you the address. It is this, WUCOs, okay? That's what it looks like. And in WUCOs, basically, it is a web page. You just log in there, and that's what it is. basically what WCALs will tell you is those KC values, those conversion factors. You have to mention, you have to write down what is your city that you are, and you just click enter and it will come a huge list of plants. I'm not a gardener, I'm really sorry. I maintain my garden, but I'm not a gardener. But it comes like 300, 500 number of plants. And when you select the one that you want, it will tell you if it is in the category of high consumption, moderate, medium, low, or very low. What does that mean? That it uses 70 to 90% of this reference CT of the plants that the grass, the water that the grass needs, or 40 to 60%, or 10 to 30%, or less than 10%. So you have both, you have the ETO and you have the conversion factor for every plant. It is, guys, this is super cool. In other states, in other parts of the world, people don't have this. This is how it looks. You type here. Let me see if I can go there. Here it is. Okay, so let me just do something here. Yeah. Okay, so this is CIMIS. This is, I logged in, so let me see. This is how it is. You go to CIMIS. So you have to log in here. It comes something like this. In data, you can actually take a look here at the, in stations, you can put the map, which that's the one that I show you, and you can kind of zoom in, and you have here the Napa station, the 187, the 157. So info for Point San Pedro, or this one for Black Point. 157. We can go 254. This is in Oakland. I was thinking I took, yeah, 171. This is the one that I was using. But you can see that there are many stations around, okay? Here in data, so 171, it will be this Union City. It says that it has data since 2001. So you can go here, create a monthly average ETO. You can put it in English units. If you want, we can do it in that. Run the report. Yeah, this is the average ETO for January, February, March for that station. That is super easy. So basically, this is how you can download that data. You go to the map, write down the station, go there, average ETO, you get it. This is super nice. If you don't know how to get this one, again, something that I do want you to remember is that there is also this map here. This map is available, and this is something super easy to get that. Now, the next thing is these WCALs, okay? So here we go to WCALs. Here, this is the plant search database, okay? Here, okay, so now in my case, so I live in Davis, California. So here it is Davis, search for plants. And basically, remember what I told you, the 300 or the 400? So look all the plants that they are there. Oh man, it's a lot of plants. So basically what you can do here is, rather than just trying to scroll everything, so for instance, Control F, and I have, I think I have a salvia. So here it comes one of the salvias, and we have a 97, and I think I have one that is this one, Salvia Mexicana. Salvia. I know I have that specific plant that is called Salvia Mexicana. It's Mexican sage, Salvia Mexicana. It is a shrub, and super important, here it says in the north central coast, in the Central Valley, where I am, it is very inappropriate. So don't put it in there. But typically it uses moderate to medium. What does that mean? Oh, I think it is in here. So moderate to medium, it uses 40 to 60% of the ETO. So of those values that I download, I multiply by 0.5 or 0.6, and that will be the amount of water that is needed. Okay. This is what is going on here. Something that I do want to mention, it's the following one. So again, I can go to Davis. Oh, here it is. So now, here I can actually, if you are designing your landscape, you can select, for instance, I want perennials or shrubs with very low water use in Davis, California. You search it, and it will provide you only the list of plants that are very low and low water use, that are shrubs, and that are, I don't know what was my other, but basically this one, it will tell you what are the ones that you want. So look, there are super nice ones. So in the Central Valley, this is a very low, Alsea rosea, perennial hollyhock, perennial, California native. The other thing that you should know that is super important, the low and very low, they are natives. Okay, so that is the other way that you can do. Now, the next thing that I'm going to do is I'm gonna show you, or I'm gonna provide you a spreadsheet, a calculator, where you can calculate your water use of your plants. So basically what I'm doing is your homework, guys. What I'm doing is actually putting all the numbers in there. So you can use this tool to calculate your water demand, okay? Now, here it is. So this, I'm gonna need 4 things. Typically, I'm gonna need 4 things of your landscape. So this, the ETO, the percentage of ETO, it will come, this comes from Wookles, okay? You will have to go and, what I was telling you, you draw your sketch of your landscape, write down where are the plants, and you will have to look those plants in Wookles. There is no way around. I cannot do that for you, okay? So you will go in there, write down your plants, and then look for those plants in Wookles. In Wookles, it will tell you this high, medium, or moderate. So basically this one, the salvia that I was looking, it was a medium. So it is 40% of the ET. That's what I put 0.4. The next thing that you can do is the height of the plant. Typically, oh, give me a second. Okay. Okay. Got it. Typically, the root of the plants is about the height of the plant. It is more or less a rule of thumb. Let me see. Okay, we have someone that is not muted. Okay, I think. Almost there. I think it just muted. Okay, so as a rule of thumb, the height of the plant is the size of the root. Okay, so if you measure the height of the plant, is more or less the diameter that you want to cover. So if you multiply if you do the square of the height, it will be the area of the root zone underneath of the plant. So this is super simple. You just go measure the height of the plant and you just put it in here and it will give me the area, okay? The emitters, you have to tell me, you have to figure out if you have one of these that are the multi-stream drippers, if you have regular drippers, or if you have any of these kind of spray jets. These are super typical on Home Depot or in Lowe's, in anyone. This one you have to actually go in there and say like, hey, you know, I have or I want to buy a dripper of 1 gallon per hour or 2 gallons per hour or half gallon per hour. All of the ones that you buy, look in the back and they actually tell you how many gallons per hour, okay? This is the same. These emitters, they have the same. It tells you, so basically I'm providing you here. Let me zoom in here. Only you need to fill these cells in salmon. This that you're gonna get from Wookles, this, that is the height of the plant. So I'm gonna estimate for you the area. The emitter that you want to put, so multi-stream emitters go from 0 to 14 gallons per hour. Drippers, there are only 3 times, 0.5, 1, and 2 gallons per hour. Spray jets go from 0 to 30 gallons per hour. That one you have to look in the back of your, when you're buying the meter, you have to look in the back of the envelope, okay? The next thing that I also want to know is the number of days. How often are you gonna irrigate? Are you gonna irrigate every day? Are you gonna irrigate every 2 days? There are certain cities that they allow you, so for instance, odd numbers, only Monday, Wednesday, Friday, Saturday, or Sunday, and so on. Or you want to irrigate every day. With these 3, basically, in here, this is the ETO of, in this case, Union City. This will be the ETO, or this reference evapotranspiration, but now multiplied by the crop coefficient, this conversion factor from the grass into the plant. So that's why you see that this value, so let me do something that it will be easier. So if the crop coefficient is 0.5, it will be that is half of the ETO, half of the reference evapotranspiration. So as you can see here, this is the reference and the plant use, the conversion factor is half of it. So that's why this column is half of this, okay? If it was 80%, this column will be 80% of this column. I'm converting here in gallons per day. The next thing is that I'm putting here the average precipitation. And this is basically accounting that you don't have to irrigate every year. Oh man, let me just, no. Just give me a second. Anyway, I'll be able to log out here. This is the precipitation, and this is also super important. Let me see if I can log out here. Turn off, here you go. This precipitation basically tells you that sometimes even though the plant is transpiring because it's raining, you don't need to irrigate. So look, here the precipitation is 2.1 and the average is 0.6. So it is precipitating 2.1 millimeters and what you need is 0.6. What that means is that in this month, you don't need to irrigate because it's raining. That's basically what it's telling you. With the precipitation here, I'm adding the precipitation to include that when it rains, you don't have to irrigate. And this will be the irrigation in minutes that you need to do. 2.5, 8, 8, 7, and 5. So basically you can round this to minutes. When you are putting either your timer or when you're moving your irrigation device, the timer, in the first month, so for May, you have to put 3 minutes. For June, July, here it is. I'm sorry. For June, July, and August, 8 or 9 minutes. In September, 5 minutes, and then in the rest of the day of the months, you don't need to irrigate. Now, this was only for one plant. What you need to do is to go into so you have, I'm pretty sure that you have a lot of different things around the house. So again, draw your sketch. In each of your sketch, figure out what are the plants that you have. For each plant, and each plant, you may have different circuits. So circuit 1 is irrigating these 3 plants or these 5 plants. Circuit 2 is irrigating this. You group the plants by circuit. Now that you have all those circuits or all those lines and the plants, for each plant, you will go here and say, well, now I have another plant that it tells me that is high. So it is on the 0.8, on the 80%. But that one has an emitter, one of these spray or multi-stream of 2 gallons or 3 gallons. And basically I will go here. Oh, the schedule is 0 here, 1 minute here, 5, 9 minutes here, and 6. So basically you will have to compare the different plants that you have on the same circuit. Let me be super specific here. This is the schedule for our plant number 1, okay? So this will be plant 1. This is our Salvia Mexicana, so that's the one there. So this is the number of minutes, okay? Here, I'm just being a little bit kind of not that well arranged. Our next plant, it is high, and it's 0.8, or you can put it, you really want to have that plant water, so 0.9. It is on the high consumption, 90%. And for that one, you have an emitter of 5 gallons, okay? So that plant have this specific schedule for those months. And this is in terms of minutes, okay? There you go. And plant number 3. This will be a very low volume, let's say 0.3. That one has a dripper of 0.5 gallons per minute, okay? This will be the third one, okay? So we have plant 1, plant 2, and plant 3. This one, pretty much you need to look at the meters and the crop plan. In this case, so in April, you need to at least irrigate 1 minute, which is the largest number here. So this plant doesn't need any water, This need 1 minute. Out of these 3 plants, this is 3 minutes, 3 minutes, 0 minutes. So you need 3 minutes here. You need 8 minutes, 6 minutes, and this one 19 minutes. 9 minutes, 6 minutes, 21 minutes, 21 minutes. So I'm just going to the largest one, and so on. So something that you can see here is that even though this plant it is the native, it is the one that requires more time because the meter is super short. The meter is half a gallon. So this plant, it has the lowest KC. It is using less, but because the meter is super tiny, it needs more time. So you can now play here like, well, let's say that I put a 2 gallon per hour emitter, and this will be reduced for that plant 3. So now this one will be 1 minute, this one will be 3 minutes. Now here the largest is 8 minutes. This one is 9 minutes, 8 minutes, 5 minutes, and 1 minute. And this will be the schedule for your timer. I think here the more than giving you a recipe, what I'm giving you is kind of the principles. And the principles are that it matters what plant you're using, because this will divide this KC, this conversion factor from grass into the plant. How big is the plant? It will tell you the area that you need. The meters, it will increase or reduce the time, because the meters is the valve, is how fast or how slow you open it, and how often do you irrigate. If you irrigate every day, every other day. So I'm gonna open for questions, but before I do that, the other part that I do want to mention is this. So this information that you're seeing here, I'm gonna send it to Louis and to the rest of the people, so he will have it. I'm gonna also upload the video so you can come back. I'm gonna upload the map, the ETO map, so you don't have to look anywhere. It comes in a map. You can actually have these numbers here. What I will suggest is that you use this calculator and you just play with this. The ETO, well, this, you look for your plants in bushels and find this conversion factor, this percentage. The height of the plant, it will give you a rough estimate of the area. The meters, you have to look in the back of the envelope and see what is the meters that you have. Okay, if you already have ones already installed, then you will have to look what is the brand, and then how often do you irrigate. With that, you can play around of how many minutes do you need to irrigate, considering that I'm also thinking about precipitation, that you don't have to irrigate in summer. Also, something that I do want, sorry, many things. Your water bill, it comes from two things. It comes from the water that you're using, but also it charges the sewer system. Your sewer system is estimated typically from October or November to March. So the water consumption that you're using from October to March is pretty much what is used to calculate your sewer consumption. Because in theory, you should not be using water for the landscape. If you're irrigating in those months, the city is charging you for water that you're irrigating that is not going to the sewer, but that the city is thinking that is going to the sewer. So you're gonna save using this by not irrigating during winter, and also by irrigating a little bit more consistently on your monthly dates. So I think that's it. Anyone has a question? Sorry, it was a lot of information, but needed. I know it looks a little bit daunting with a lot of these things. I think what you really need to concentrate is in here. Something, one, sure. So, yeah, so this is where I live. This is my house. Basically what I was, so as you can see, we have a lot of fruit trees, okay? So we have an almond tree, we have 2 apple trees, 1 peach, 2 plums, and 1 lemon. In the front, we have these 2 large trees, these 2 small ones, the Salvia Mexicana that I was telling you. We have here a lot of rosemaries. This is our garden box. This is our salsa box. So that's where we grow our salsa. Here are the crop coefficients for trees. So trees use a lot of water. So if you want to also estimate your trees, so these are apple, cherries, pears, apricot, peaches, stone fruits, grapes. These will be some of the ones. I also found, so this is the document where I found a lot of that information. Here is also for alfalfa, broccoli, lettuce. Somewhere here should come the tomatoes and so on. These are also some crop coefficients for that. So I'll make sure also to include these on your spreadsheet and on the documents. I think for now, I don't want to leave you with how am I gonna do this? Really, draw and sketch, find out, have a list of your plants. And from that list of plants, go here to vocals, look for them, look for that crop coefficient, take a measure the height of the plant, and see if you can change the meters or not. And from that, guys, the spreadsheet will estimate the minutes. It is that simple. That's what you need to do. And also, I'm gonna leave Louis my email. So if you want to contact, I'll be happy. Anyway, any comments, questions? Lorena raised her hand. Where is Lorena? Lorena, can you talk? Lorena. Lorena, can you unmute yourself and ask the questions? Oh, so wow.
Oh, here, hi.
Yeah.
Thank you for the information. We've had a little of this, but it is overwhelming. I want to know, in your garden, do you have to have the same emitters on all the plants?
No. No.
Okay.
You can play with them. So basically, what I did is try to, so we irrigate every morning like 6:30, 7 a.m. And we change the emitters. So we are kind of trying to match the EP. Mm-hmm.
Yeah, because I have maple trees on one, and on the same valve I have drought tolerant. So I have a different emitter, you know, one that you can turn and it sprays out more. So
yeah, and that's the way to go, the mix and match. Mm-hmm.
Okay, I didn't. Thank you.
So Lorena, if one of the meters, I was worried that I have a low water and high water plants on the same circuit. So this is Gail Mayers. Seems like we'll be okay as long as I have the right gauge emitter. Yes, that is correct, Gail. I don't know where are you, Gail. But yeah, so you may have on the same circuit two different plants. In one, you have to put a high emitter, a meter with high gallon per hour, and in the other one, a drip low one. Mm-hmm. Yep. Is the calculation of the plant area if some plant is spallier fruit, a 3-4 foot tall, but it spans, oh, okay, no, that doesn't match. So, the typically, again, so the height of the plant, it will be the height of the length of the root. But if your fruit tree, it is 4 feet tall, but it is like 10 feet this way, actually it has to be it's very likely like the width of that tree, which is 10 feet, it is the same amount of the roots. The plants to be stable, they have to be the height is the root, so they will not fall. So in that case, the 10 feet, you have to multiply times by 10. It will be not the height, but the width. Mm-hmm. Any other comment, question? So for your chart, if you water once a week, how do you enter once a week? Oh, okay. So it will be every 7 days. So how often? 7 days. Or how often? Every 3 days. How often? Yeah. It will be a lot of water. Something that I do want to, you have to add extra water to your fruit trees, when is the best time? Okay, so that is Jan. Okay, so for tree crops, any tree, you don't want to torture the tree. You don't want to under irrigate when before the flowering. So before any fruit produce the flowers, do not stress the plant. So while they are kind of flowering, that's when you're actually going to get the fruit. After that, then you can go a little bit low. But the reality is that when it is growing before the flowering, don't do that. Mhm. If you have to add extra water to your fruit trees, when is the best time? So it will be before. Everyone has a different limit. Okay, so let me just share this super fast. So I'm trying to make all of this kind of scientific stuff more digestible. Sometimes when I do this, I think that it's like talking with a doctor when they telling me what are my illness and I don't understand even though they are speaking plain Spanglish. The same I think is here. So any plant will have an initial stage, then it will develop, and then it will stay full canopy, and then it will go, you get the fruits, and then they will, all the leaves will fall. And then again, it will develop, it will stay with all the canopy, and it will go down. So when you're asking me about the trees, this is exactly the same zone. Stay lows, this is fully developed, and then it will go down. If this is low, this is fully developed, and then it will go down. This is slow, fully developed, go down. So before it is fully developed, I will not stress it. So the answer will be June. For many of the trees in this table, you can see that this one is 1.2 or 1.1, 1.1. This is fully developed, the highest value. Here, 0.8, 0.5, 80, that is the highest value. This is fully developed. So pretty much, if you have some extra water before June, after June, you can stress it. Once it has fully developed, it will be okay. Any other comment? I'm looking for my chat here. Oh, here it is. Okay, I went really back from your chart. Okay, I'm really back on the questions. Sorry, guys. Let me see if I can go super fast on this. I went that. So for your chart, if you water once a week, how do you enter once a week on your chart? Every 7 days. When you say, for example, to water 5 minutes, it is 5 minutes per week. Yeah, it will be 5 minutes per week. So you put how often every day, and it will tell you how many minutes on that irrigation event. If it is 7 days, how many minutes on that one? If it is better to bury emitters so there is no loss in evaporation, yes, that is true. So there are irrigation pipes that actually you can punch it, or that they have the meters on the pipe. And when you put it close to the root or bury it, that is better. In the jargon, we call it you're taking the E from the EP. So you're taking the evaporation from the evapotranspiration. That is super true. If you bury the pipe, that will be better. Different vegetables require water in different quantities. That is correct. So the drip line is okay for all of them? Yes, the drip line is okay. But again, the meters, you have to adjust the meters depending on the different vegetables. Mhm. Is there any consideration of location of the plant in the sunny, shady? Oh, okay. Yes, there is a consideration. So remember that when they say high, it's 0.7 to 0.9. When it says moderate, 0.5 to 0.4 to 0.6. That variation of the KC, of the percentage, it will be for the sunny or shady. So if it is in the sunny spot, it will have to go 0.6. So let me actually, in here, sorry. So this will be the 70 to 90. It's because the 90 is in a sunny spot and the 70 is in a not so sunny spot. The 60 to 40, it will be for that. Mm-hmm. But I mean, I'm pretty sure, you know, plants are like us. I mean, each of them are kind of their own individual. And some of them, they are kind of super large and you need to put some more water than others. Mm-hmm. Is there any concern? Oh, yeah. What about the age of the plant? Well-established plants generally needs less water than, yes. And well, so this is Laura Fairbanks. Thanks, Laura. And also thanks, Bob, Durga. So Laura, your response will be this. Well-established plants need less water because pretty much the roots are deeper. And because the roots are deeper, they can tap to the water that it rains during the winter. That is typically what happens, okay? So that's typically what happens there. Yeah, they need less water. When you are trying to establish a plant, so the first year when you're trying to establish, do not under irrigate. Go to these kind of higher values. Once the plant has passed 1 year or 2 years, it is well established, you can start torture the plant, but before don't torture the plants when they are just growing. Lucia, where are we going to find the documents? I'm gonna send it to Lou. Please contact Louis Asbury. Louis, can you type your email or where are they going to get this information on the chat? Lorena is asking a very good question. How many days would you recommend in the sandy soil? Okay, so now this is a very good question. You're really into your gardening. So sand soil, it moves water faster. And that is compared to clay or to lime. So clay and limestone, they will be very difficult. So the water stays there. If it is clay or if it has a lot of fines, super fine that are not sand, it will stay, the water will stay there for longer. So you can irrigate every other day or every third day. In a sandy soil, you cannot irrigate every third day. Because basically what you irrigate on that day, it will pass through the root zone and it will go to the ground. In a sandy soil, you need to irrigate small amounts, but more frequent. If you put your hand in the soil and it is like clay or it looks a little bit muddy, that is not sand, then you can irrigate every other day, every third day. Mm-hmm. Okay. Then Anne Sutherland. What about mulching? Is there an adjustment for that? Okay, so mulching. Yeah, you really know your garden. Mulching prevents water to evaporate. And mulching, basically what it does is when you irrigate, it will go under the mulching and it will prevent the evaporation. That will be, yeah, you will have to adjust rather than going on these kind of higher values of 1960-30, you will have to go in the middle, more or less. But the best advantage for mulching is that as it is raining, it will go down and it will prevent evaporation. Is it better to use drip line around fruit trees like pomegranates? Yeah, yeah, you can use a drip line, but the ones that I've been having a lot of success is this one. These adjustable multi-stream drippers, because you can adjust it for 5 gallons, or you can buy the one of 5 gallons or 8 gallons. And that will be, then you run your irrigation 10 minutes, 12 minutes. But this one, because they put a lot of water, it will make the trick. It will provide the right amount of water for the trees. Now, for the ones that are still here, let me tell you a little secret here. So, okay. So remember that I start talking to you about that it will be super difficult to estimate the water needs for all the plants, and that we have something that is a template, and the template is this well-watered grass. Okay. As you can see here, all of these plants use less than 100%, less than 1. Okay. What that means is that the grass used a lot of water, guys. Grass used a lot of water. It is impressive. It used a lot. Actually, I can tell you how much water used the grass. So this is in millimeters. Let me put it in inches. So this is pretty much 2 feet. This is 2 feet of water of grass. Imagine that the place where you have a grass, you flooded that with 2 feet of water. That's how much water the grass needs. It's a lot of water, guys. And then the other thing that is important is that every week or every 2 weeks, you mow it and you put it in the curbside, and someone takes it out. And then the next week, all over again. So this is for these trees. So in this case, 15% more of the 50%, 25, 25, 20, 95% of the grass. Trees use more water than the grass. This will be 0.8, this 10% more, 20% more, 20%, 15, 70%. This is, if you now start thinking about that with that template, now you can start seeing like, oh, this used less than the grass, more than the grass. Natives, they use up to 30% of the grass. These are, even though they save you water and so on, they are super adaptive. It is more environmentally conscious. I understand the green white picket fence with the green yard in front of the houses. We are using a lot of water. Okay, so yes, I can forward to Contra Costa. More on mulches, including water conservation. In the UCNR, oh, this is my colleague, Don. UCNR publication mulches. Also, he's putting a link there for the mulches. I'll send this to Louis, and make sure to contact Louis. This is for Contra Costa. What are the other counties that we have that people attended here? Because something that I can do here is just to, in this spreadsheet, have here another table where I will say this county, this county, this county, and you can copy and paste here the values and here the values, and you can adjust it for your area. I know this was a lot of information. I'm sorry, guys. But yeah, no, nothing to thanks, Aisha, de nada. Alameda, Contra Costa counties. Okay, Alameda and Oakland. Yep. So anyone else has other questions? So I think we're good. This is a super nice example. Do not hesitate in contacting Lu. Oh, before actually, this is my. So that is my email. I sent it to Lucia, but I think I sent it to everyone. So that is my email, samsandoval@ucdavis.edu. One other thing before we actually finish. Stay safe, stay healthy, do your gardening. This will pass. I really wish you the best. I really wish you the best. We'll be fine. Enjoy the time on the sun. Oh, yeah, June Wallace, yeah, that is correct. Cautionary comment, all irrigation systems need constant monitoring. Yeah, we didn't thought about it. Talked about it. If you want to monitor, so if you do not know how much water are using your emitters, here is something that you can do that it will be painful, but you can do it. So underneath, so take a can of whatever, it can be a tomato can or any can, okay? So you dig a hole underneath the meter and put the can underneath. Once you put the can underneath the meter, then you start running your irrigation system, and pretty much that water you put it in a measure cup and you estimate. So you have to time when you start your irrigation and when you finish. So when you do that, basically, and collect the water, you put it on a measuring cup. You can estimate how many gallons or how many ounces, and it will be those per minute, or those, you can calculate those per hour, and that will be how many gallons per hour is giving you that emitter. So if you don't want to change anything, you will have to start digging a lot of holes underneath your emitters and put it cans in there, and you can measure that. Hey, Maria. Yeah, thanks. Thanks, Maria. Margot, thanks a lot. Michelle, thank you. Nancy, Lucia, Dunga, Liv. Anyway, this was super fun. Thanks, everyone. Have a good week and have a good week.
Okay.
Have a good one, Louis.
Okay, thank you. Cheers. Thank you very much. Thank you, everybody.
Have a good one, Gillian.
Cool.
Anne, William, Annie, Ray, Dave, Catherine, Sonia, Ken, Bonnie.
Can you please repeat the email address, your email address?
Oh yeah, it's Sam Sandoval at ucdavis.edu.
Did you put in the chat?
It is in the chat. Let me
Okay, I'll see.
let me put it in there. It is back there.
Oh, okay.
Good one, Annie.
Sandoval. Okay, thank you. I will note down.
Have a good one, Durga.
Thank you. You too. Thank you very much, sir.
Yeah, thanks.